Welcome to Chemistry Online. Today we're going to talk about the physical property density. Density is simply defined as the mass of a substance divided by its volume. Typically we will use units of grams for our mass and cubic centimeters for our volume, but you could use any units for either one. One unit that we use a lot in chemistry is a liter. A liter equals 1,000 cubic centimeters, and 1/1000th of that is a milliliter. Remember, 1 milliliter is the same as 1 cubic centimeter. Density is typically referred to generically as mass per unit volume. For example, if we had 1 cubic centimeter of gold, and I tell you it weighs 19.3 grams, the density, mass divided by volume, is simply 19.3 grams per cubic centimeter. Some common substances. Water. Water has a density of about 1 gram per cubic centimeter. That's pretty much what it is at 4 degrees at room temperature. It's closer to 0.996. Mercury, much more dense, 13.5, a liquid metal. Sulfur, 1.96, iron, about 7.8. The gases helium and oxygen. In terms of grams per cubic centimeter, these are very small numbers, and quite often these will be expressed as grams per liter, so we don't have to deal with the leading zeros. This is a very interesting little video clip. Here we have a gentleman standing in front of a pool of mercury, and he's holding a cannonball. Drops the cannonball in, and it floats. Cannonballs don't float on top of many things, but in this case, the iron cannonball floats because its density is 7.8. Mercury, the liquid, is 13.546 grams per cubic centimeter. Let's do a couple of simple problems. If we have 250 cubic centimeters of a gas and a mass of 0.45 grams, what is the density? We remember density is mass per unit volume. All we have to do is take our equation, substitute for mass and volume, and our density is 0.0018 grams per cubic centimeter. We're dealing with two significant figures. Density of ethanol is given as 0.79 grams per cubic centimeter. What is the mass of 15 cubic centimeters? We're going to solve this problem using our given ratio algorithm. For our ratio, we're going to use the density expressed in terms of grams over centimeters. We start off with our given. Our ratio must have the units cubic centimeter in our denominator. They cancel. Do our simple math, and we have 11.8 grams. Now I want you to look at the significant figures in this problem. We have 3 significant figures given in our density. We have 4 given in our volume. But if you look here, we have 1 cubic centimeter given in our ratio. This, however, is an exact number, not a measurement, and does not count in determining significant figures. We could do the same problem just starting with our equation. Mass divided by volume. Solve here for mass, and we substitute. You'll note that this is the same form as we had in our algorithm. Here's our given, and here's our ratio. Density of mercury is given. What volume is occupied by 999 grams? Using our formula, density is mass per unit volume. We're simply going to solve here for volume. You'll note that we have grams in the numerator and the denominator. They will cancel. And we're left with cubic centimeters in the denominator of the denominator. Whenever you have the reciprocal of a reciprocal, well, that's what you started with. That means that our cubic centimeters here will go up top. And we'll solve this thing simply as 73.7 cubic centimeters. Again, 3 significant figures. If we solve this using our algorithm, we're going to use our density as our ratio. Our given is our mass of mercury. Here's our given. We put in our ratio. But we realize that the units of given must appear in our denominator of the ratio. So we're going to invert this. Now we can cancel. And of course we get the same result. Another simple problem. Here we have two liquids that are immiscible. We're given densities for liquid A and liquid B. In an immiscible liquid, they do not mix. The density determines which one will float. In this case, liquid B, the lowest density, will rise to the top. Think about the cannonball floating on mercury. Finally, in lab, you're told that you need exactly 2 grams of acetone for an experiment. You're given the density. How many cubic centimeters or milliliters will you need? Let's use our algorithm. Here we're using our 2 grams as our given. Our ratio is simply our density. We set it up so that cubic centimeters are in our denominator. Grams are in our denominator. They cancel. And we're left with 2.53 cubic centimeters or 2.53 milliliters.